So we were discussing about the CPU pipeline stages in Raspberry Pi. Okay, so we have studied that in Raspberry Pi, ARM 11 core processor has been used, and this ARM 11 core processor is using pipeline method to introduce parallelism in its execution of instructions, and this will lead to increase in computing power of the CPU. Okay, so last time we have discussed about uh, three-stage pipeline. Okay, generally a single instruction is divided into three stages: fetch stage, decode stage, and execution stage. And these three operations are overlapped. That means all these three operations are carried out simultaneously. And last time we have seen that when initially instruction 1 is fetched, during next clock cycle, instruction 1 is decoded, instruction 2 is fetched. During third clock cycle, instruction 1 is being executed, 2 is being decoded, and instruction 3 is being fetched. So the pipeline goes like this. And if the number of instructions are very large, then almost at a single clock pulse, one instruction is executed. So this is how parallelism is introduced into CPU pipelines. So this is the method in which the uh, parallelism is introduced. And here the design simplicity depends upon whether how is your instruction. So instruction should be simple and all instruction length must be equal. Okay, so if this is followed, then pipelining will become a simple task, and it will provide a magical result. Now, pipelining will encounter one problem, and that problem is that uh, serial execution starting from first line to last line is no problem. But if it has loop, if it encounters interrupt, if it encounters jump instruction, then in that case, the program execution path is going to change. And when this program execution path is going to change, at that time, the whole pipeline must be flushed and execution must start from the location that is provided in jump instruction. Okay, so for this, it will need extra software or extra hardware. So this issue must be addressed in CPU pipelining. Okay, so this is what you have to remember. But in case of this ARM 11 processor, what you have to remember is only that initially ARM core, it was also using three stages of pipeline. But afterwards, with advancement, it is using 8 stages. Okay, and each stage is assigned with a particular function. Okay, and here you can see that all these stages they are overlapped, and in output of one stage will be given as input to the next stage. So that is what is happening here, and that is what you have to remember. So here you can see in the diagram, what you can observe, there are 8 stages: 1, 2, 3, 4, 5, 6, 7, and 8 stages. So 8 stages are there, and these 8 stages are constructed to use the pipelining in CPU. Okay, so here you can observe FE1 and FE2. These are two fetch stages. Instead of a single fetch stage, two fetch stages have been introduced in this 8 stage pipeline of ARM 11 core. Okay. Now that means you can fetch more number of instructions in advance. So that is what is the purpose behind this. Now, after this, what you can observe is there is instruction decode stage here. As you can observe, DE. DE is a instruction decode stage, and after that, ISS stage is there. ISS stage means one issue stage, one issue stage. Okay, so this particularly is register read and instruction issue. So two operations are taking place at a time here. The register is read and instruction is issued. So this stage is called as ISS stage. Okay. Now, four integer execution pipelines have been provided here. These next pipelines, one, two, three, four stages. These four stages are for execution of four integer instructions, integer type of instruction. So, in order to execute these type of instructions, here you can observe execute one stage, execute two stage, and execute three stage. So, three stages have been used here. Okay. So, different types of pipelines here, as you can see, shift operation is always needed in case of such type of processing or computing. So shift operation is provided here. And as you can observe here, MAC 1, MAC 2 and MAC 3. So these three stages are there. Meaning of MAC is that multiply and accumulate. Multiply and accumulate means number of multiplications have to be calculated and they are added together. So such operations are generally used in this type of processing. For example, suppose if you are going to perform correlation operation, then if you see the formula for correlation, then it will contain n number of terms, and these n number of terms are nothing but multiplication, and correlation is nothing but summation of these n number of multiplication terms. So multiply and add, multiply and add. So multiply and add is also called as multiply and accumulate. Accumulate means um, current multiplication is added to previous result. So such multiply and accumulate stages are suitable for calculation here. And these stages here you can observe there are three stages. During first execution, MAC 1 is there, second execution MAC 2 is there, third execution MAC 3 is there. Okay. So here you can observe three number of stages. In the first stage, you can observe shift stage. Okay. In second stage, here you can observe there is a ALU operation. Okay. And in the third stage, what is called as saturation operation is there. But basically, what is happening here? Shifting and multiplying and addition. So these type of operations are taking place here. Okay. So load or store a pipeline is the last stage of this. Okay. Last stage here, as you can observe, base register write back and write back from LSU. Okay. So these two things are there. So you need not remember all these things. What you have to remember is the order of execution and the number of stages and names of these stages. Okay, so that is what you have to remember. Okay, so here if you can see here what are the stages. Basically fetch stage can hold up to 4 instructions. Okay, and here branch prediction technique is available. Branch prediction means as I told you, when branching occurs, the pipeline has to be flushed and it has to start with some new value. So in that case, some time will be wasted to do all these things. But suppose if your pipeline is capable of predicting the branch earlier than it occurs, then CPU will earlier work on it, and then it is going to flush the pipeline quickly and start the operation quickly. So this type of method is called as branch prediction technique, and this branch prediction technique is available here. So as you can see, issue and decode stages, they can contain any instruction in parallel with this predicted branch. Execute stage is there, memory stage is there, write stage is there. So after execution, result will be produced, and this result will be required to be either stored into the memory or written somewhere else. And for this memory and write stage, that is last stage shown here, that is used. Okay. So these stages are executed in order from 1 to 8 in one single clock cycle. Okay. So here you have to consider that large number of instructions have been executed. So same type of operations, if they are repeated number of times, then this type of architecture is very useful. And the same thing is happening in case of embedded system. The same number of calculations may be on different set of data that is carried out continuously, and this will be beneficial. This type of architecture will be particularly beneficial because these 8 operations, they can be performed in a single clock. So instruction is executed per clock cycle. So this is one of the important feature of this pipelining architecture. Okay, so just what you have to remember is 8 stages are there, 2 fetch stages are there. They are going to fetch 4 instruction in advance. So first page stage, second page stage, then instruction decode stage is there, register read and instruction issue stage is there. For shift operation, shifter stage is there, main ALU stage is there, which is going to perform the arithmetic and logical operations, and thereafter saturation stage is there. This is also going to perform arithmetic and logical operations in second stage, and write back stage is used to provide the results or to store the results in the memory. Okay, so this is what is happening inside the central processing unit of ARM 11 core type of architecture. Okay. Now, this type of architecture, as I told you, is also called as superscalar architecture. Superscalar architecture was introduced by Intel in its Pentium type of processors. Okay, so it can run a number of instructions in parallel way. Okay, so here you can see uh, 3 instructions, 3 mathematical integer instructions can be executed in parallel. As you can see, there are ex1, ex2, ex3 stages are there. Okay, so this parallel processing architecture is called as superscalar architecture. So this superscalar architecture, it implements pipelining for parallelism. So that is what you have to remember for this. And for this is used for integer operations. There is a separate coprocessor for floating point operations, and that separate coprocessor for floating point operation is called as vector floating point coprocessor. Okay, so this coprocessor meets all IEEE standards for floating point arithmetic. Okay, and these floating point operations, they are performed by separate coprocessor, and therefore the performance, overall performance of the system increases. Okay, so with help of this floating point processor, it is capable of performing single precision as well as double precision computations. Okay, so this is very important. So this coprocessor, floating point coprocessor, is 10 times faster as compared to this integer processor. Okay, so it is going to provide a very fast floating point operation. So floating point operations are complicated as compared to integer operations. Integer pipeline is rather simple type of pipeline, and hence the concept is for your study. But floating point operation, it consists of complicated pipeline implementation. Okay, so that has not been provided over here. Okay, now let us go to next type of architecture of your ARM 11 core processor, and that is cache organization. How cache memory is organized. Okay, so here what you can observe in the diagram, you can observe uh, there are two memories. One is tag RAM and another is data RAM. Okay, and in all whole this type of memory is called as tightly closed memory. So it is called as tightly closed memory. Okay, now here as you can see, there are two types of memories which have been used here. This is called as Harvard architecture or Harvard implementation, a separate memory for program or instructions and a separate memory for data. Okay, so as memory is separate, bus should also be separate. There is a separate set of bus for instructions or programs you can call, and there is set of separate buses for data memory. Okay, now as you have studied cache organization during your first year, so all of you know what the cache memory is. Okay, so this can be directly accessed by your central processing unit. So if you consider memory hierarchy, then registers which are present in CPU, they are at highest level, and after register, there is a cache memory. So registers, they are operating exactly at the same speed as that of your central processing unit. So cache memory is also nearly running with the same speed as that of CPU. So this is very high speed, small amount of memory which is present between your central processing unit and main memory. And purpose of this is to store most recent references of the CPU so that they can be immediately copied by your central processing unit. Okay, so all addresses of these, they are already ready there, so they can be immediately accessed. There is no need of address formation and all those things which are very time consuming. So use of cache memory in any processor architecture is going to increase the speed of performance. Okay, now here in case of your ARM 11 core processor, there are two type of cache, D cache and I cache. D cache means data cache, I cache means instruction cache. And even the cache memory is used in two levels, level 1 and level 2. Level 1 is the closest to CPU, and after level 1 there is level 2 memory. And you might be remembering L1 is made up of static type of semiconductor memory, and L2 is made up of dynamic type of semiconductor memory. So type of memory that is basically used in case of this ARM 11 core processor is called as four-way set associative cache memory. So you might have been studied about such type of memories, which are associative memories. Associative memories are fastest type of memories, and they are used to implement the cache memory. Okay. Now, what is specific characteristics of this associative memory? The specific characteristic of associative memory is that it is content addressable memory. CAM, it is also called as CAM, content addressable memory. So this particular memory can be addressed by its content itself. There are no separate addresses assigned for the memory. So by content itself, that particular memory is assigned. So this type of memory is called as associative memory, and this associative memory is used to implement the cache memory of ARM11 core processor. Now, in this case, four-way set associative memory is used here. So, four sets are used in parallel to access this type of memory. So again here the speed of memory access is increased with help of this. So what is time consuming in case of accessing memory is calculation of addresses, translation of addresses from logical address to physical address. Now suppose if you are using or referring the memory by content itself, then this particular stage of address translation or address calculation, it is omitted, and as this is omitted, the speed of the memory becomes faster. Okay, so this type of implementation have been used in your cache memory of core ARM Core 11. Okay. Now, here one more thing you can observe is there is a presence of what is called as micro TLB. You can observe here micro TLB. Okay. So, meaning of TLB is a translation look aside buffer. Meaning of translation look aside buffer is that it stores most recently referred address translation. So whenever particular memory location has been referred of your main memory, then it is going to use this translation look aside buffer, and if the translation is readily available there, then it is going to directly take that address. Okay, so this is again going to speed up the operation of the processor. Now here as set associative memory is used to implement cache, there is no need of address translation. That is what we have said. But what happens whenever the data which is not present in the cache memory is looked down into the main memory, and it is copied from main memory and to the cache again, and from cache memory it is referred by the central processing unit. So this process of copying the data from main memory to cache memory, it requires address translation, and this recent address translation, they have been stored in what is called as a micro translation look aside buffer. ओके, म्हणजे काही काही रॅमला रेफर केलेले ऍड्रेस ट्रान्सलेशन जे आहेत रिसेंटली केलेले, ते सगळे त्या TLB मध्ये स्टोअर केलेले असतात, आणि जेव्हा जेव्हा तो पर्टिक्युलर डेटा रेफर करायला लागतो CPU ला, तर तो प्रत्येक वेळेस ट्रान्सलेशन करत बसत नाही, तर ऑलरेडी ट्रान्सलेशन केलेले जे कॅल्क्युलेशन्स असतात तो डायरेक्टली त्या TLB मधून घेऊ शकतो. त्याच्यामुळे काय होतं, त्याचा कम्प्युटिंग स्पीड जो आहे तो काय होतो, वाढतो. ओके, सो आता इथे तुम्हाला दोन आर्किटेक्चरल फीचर्स लक्षात आले. एक म्हणजे हार्वर्ड आर्किटेक्चर इथं वापरलंय, सेपरेट डेटा सेपरेट कॅशे. ओके, दुसरं म्हणजे असोसिएटिव्ह मेमरी वापरलेली आहे, आणि नुसती असोसिएटिव्ह नाही तर फोर वे सेट असोसिएटिव्ह मेमरी वापरलेली आहे, ज्याच्यामुळे पुन्हा स्पीड वाढलेलं आहे इथे. आणि इन ऍडिशन ट्रान्सलेशन लुक असाइड बफर सुद्धा इथे राईट बॅक आणि राईट थ्रू साठी ऍड केलेला आहे, ज्याच्यामुळे काय होतं की तुमचा जो स्पीड आहे, ओव्हरऑल स्पीड जो आहे सिस्टीमचा, तो इन्क्रीज केला जातो. ओके, आता इथे पर्टिक्युलरली ब्रांच प्रेडिक्शन आणि फोल्डिंग कॉन्सेप्ट जी आहे ही फर्स्ट टाइम यूज केलेली आहे. ओके, आणि डायनॅमिक ब्रांच प्रेडिक्शन साठी आणि इन्स्ट्रक्शन फेच करण्यासाठी ती वापरली जाते. आता डायनॅमिक ब्रांच प्रेडिक्शन म्हणजे काय, प्रोग्राम एक्झिक्यूट होत असताना त्या प्रोग्राम मध्ये पुढे कुठे ब्रांच ऑपरेशन आहे का ते प्रोसेसर शोधून काढतो. ब्रांच ऑपरेशन, पॉसिबल ब्रांच ऑपरेशन तिथे असेल तर तो काय करतो, त्या ब्रांच ऑपरेशनचा ऍड्रेस काय आहे, आणि मग त्याचे कॅल्क्युलेशन इन ऍडव्हान्स तो करून ठेवतो बाजूला, म्हणजे साइड बाय साइड त्याचं एक्झिक्युशन अगोदरच्या इन्स्ट्रक्शनचं चालू आहे, पण साइड बाय साइड तो ब्रांच अगोदर प्रेडिक्ट करतो आणि त्या ब्रांचशी रिलेटेड जे कॅल्क्युलेशन्स आहेत तो अगोदरच करून ठेवतो. म्हणजे ब्रांच आल्यावर तो कॅल्क्युलेशन करत बसत नाही, तर अगोदरच ते कॅल्क्युलेशन्स तयार असतात. म्हणजे जसा ब्रांचिंग इन्स्ट्रक्शन येते तसं लगेचच काय होतं की ते कॅल्क्युलेशन्स रेफर केले जातात आणि मग स्पीडीली काय होतं पाईपलाईन फ्लश होते आणि मग नवीन काय केले जातात, नवीन जे तुमचे ऍड्रेसेस आहेत ते त्याच्यामध्ये लोड केले जातात आणि नवीन ऍड्रेस पासून ही पाईपलाईन एक्झिक्युशनला सुरुवात करते. ओके, सो दिस इज व्हॉट द ब्रांच प्रेडिक्शन टेक्निक इज देअर. ओके, आता याच्यामध्ये दोन प्रकारच्या टेक्निक आहेत, डायनामिक ब्रांच प्रेडिक्शन आणि दुसरी स्टॅटिक ब्रांच प्रेडिक्शन. आणि फर्स्ट लेवलची जी कॅशे आहे तुमची दॅट इज युजिंग डायनामिक ब्रांच प्रेडिक्शन अँड सेकंड लेवल ऑफ cache it uses static branch prediction. Okay, so what is different of dynamic branch prediction is that it uses history information. Dynamic branch prediction, it uses history information for prediction of the branch. So this again speeds up the process. But static branch prediction technique, this cannot do it. It doesn't use history information. It cannot use history information for the prediction of branch. So using history will speed up its operation. So that is what is the basic difference between dynamic branching prediction and static branching prediction. Okay, now what is meaning of branch folding? Okay, so this is a technique where branch instruction is removed from the pipeline and is stored in the buffer. Okay, which is executed on all dynamic predicted branches. Okay, so this technique where the branch instruction is removed from the pipeline and it is stored in a buffer, this type of technique is called as branch folding technique. Okay, so this branch folding technique is used to avoid losing the link. Okay, predicted branches that lead directly to another branch. Okay, so in this case also the this type of branch folding technique is used. So three situations are there where the branch folding technique is used: when the predicted branch leads directly to another branch, or when the branches have been cancelled even though they have already fetched. Okay, so in these two conditions you need to cancel the branch cache branch pipeline, and when this branch pipeline has to be cancelled, it has to be stored into a separate buffer. Okay, so if there is facility to store this into a separate buffer, this is called as a branch folding. So this branch folding type of technique is also available in your ARM11 processor. Okay, so this is all about the cache organization. So what you are going to remember about cache organization? It uses Howard architecture. It uses set four-way set associative memory. Branch prediction technique is used. Dynamic as well as static branch prediction is available. Branch folding technique is also available in this architecture. So this is what you have to remember about this. One more thing here you can observe here, the replacement policy of the cache is controlled by pseudo random or round robin technique. So all of you know round robin technique. So different time slots are provided to different set of data, and depending on this time slot, the replacement policy of cache has been designed. Replacement policy means all of you know. Okay, what it is: when the central processing unit does not find reference into cache memory, then what it does, there is a miss operation, isn't it? There is no hit operation. You are aware of what is hit, what is miss. So when miss occurs, what CPU will do? It will look into RAM instead of looking into cache. So if it finds the data in RAM, and that data has to be transferred from RAM to the cache memory, but space for this data has to be made, and that space is made depending upon different types of algorithm or different types of techniques, either first in last out or least recently used. So in this case, the round robin type of technique is implemented for replacement policy. So that is what you have to remember about this. So for multiple choice, these things are very important. Okay. So all this thing is given here. You can read it from this. Okay. Now, the last point of this chapter is the graphic processing unit. Okay, so this graphic processing unit is a specialized electronic circuit which is designed to uh, carry out uh, these graphical operations. Okay, generally these graphical operations are your image calculations. Okay, so if you see the block diagram, I will provide you with the block diagram. This block diagram consists of graphical processing unit, which consists of VG BIOS. What is BIOS? BIOS is basic input output system. So how to perform input output system, that those instructions are there. So you can call this as operating system, okay, which is used to perform the different operations. So it consists of graphics memory controller unit. Obviously, as this is related to image, it consists of a compression unit, because in order to implement image pictures or video type of data, the compression has to be carried out. Otherwise, data will take a very large amount of space, and which is redundant. That means which is occurring continuously. Same thing is occurring continuously, then it is called as extra or redundant, and that need not be stored every time. So it is stored only once. So this type of technique is called as compression of image or compression of the video. So compression unit performs the compression of images or video. Okay. So graphic and compute array is also there. As you are using display for graphic and video. So display interface is made available in this graphic processing unit. Bus is required, and the bus which is required for graphic processor is a special type of bus which is operating at a greater speed. So such type of bus has to be handled, and therefore bus interface unit is also provided onto this graphic processing unit. Similarly, power management is also necessary. Okay, so as display is connected to this, the power management is necessary, and therefore power management unit is available with this graphic processing unit. Apart from this, video processing unit, so which is one of the important part, or you can say a brain of your graphic processing unit is there. So videos are processed with help of this video processing unit. Number of operations can be performed on video with help of this video processing unit. Okay, now in order to implement this graphic processing unit, parallel processing is implemented here. So highly parallel structure is made, and this parallel structure is implemented to compute the images and videos. Okay, so